This is from the official SAT book, Test 6, Section 4. All right, here we go. If x minus y equals 8 and y equals 3z and z equals 2, what is the value of x? We'll just start back substituting the whole way through. Hold on 1 second. All right, so if z is 2, then y is going to be 6. And so then we're going to get x minus 6 equals 8 if I put y in there. And we're going to get x equals 14. Okay, some of these are nice simple algebra problems. Todd is older than Marta, so Todd is greater than Marta, but younger than Susan, so younger than Susan. Which one is it? Well, it's the first one. That was easy. Okay, next page. Scroll it up a little bit. If the areas of two regions are equal, then the sum of the areas of the region is x. What is the average of the areas of the two regions? I think this is kind of hard for being a number 3. So you have two regions, they're equal, so we'll just call them x. We'll add the two areas up, and it's going to be equal to 5, right? What is the average of the area of the two regions? Well, we can figure these out. It's going to be 2x equals 5. So each region is equal to 5 halves. And what's the average of them? Well, we're just going to add our 5 halves and our 5 halves. This probably isn't the way that you did this problem. It's probably not even the way I did it. We're going to get 2 5 halves. So it's going to be 10 halves. And that's going to be 5. And then we're going to find the average of them, so we're going to divide by 2. And so I do believe the answer is 5 halves. So we're just taking our two regions, I added them up, and then I divided them. I added them up, I took them times 2, and then divided by 2. And these kind of cancel each other out, so you get 5 halves. Hopefully that made some sort of sense there. Okay, scroll down a little bit. Let S be the set of all integers that can be written as n squared plus 1, where n is a non-zero integer. Which of the following is in S? Okay, so this is basically saying which ones are perfect squares plus 1. Well, we know our perfect squares are 2 squared would be 4, 3 squared 9, 4 squared 16, 5 squared 25, 36, 49, 64. It doesn't go that high. So it says, let S be a set of integers that can be written. Which of the following integers are in S? Well, if we add 1 to 4, we're not going to get anything. Add 1 to 9, we're not going to get any of those. 16 plus 1 is not on the list. We get 16, that's not going to work. 25 plus 1 is not on the list. 36 plus 1 is not on the list. 49 plus 1 is on the list. It's the only one that's a perfect square plus 1. So the only one that works is this one. It would be interesting to see everyone's way that they do a problem. There's so many different ways to do each of these. In the figure above, point O is in the center of the circle. X is 40. This is like a real easy version of one we did on the last test. What is the value of y? Here's the key for this one. O to here is a radius, and O to here is also a radius. Any line that goes from the center to a point on the circle is a radius, any segment, and all the radii in a circle are going to be equal. So that's an isosceles triangle, so you know this is also going to be y degrees. So you just take 180, you subtract 40, so you get 140. There's 2 of them, so you divide by 2, and so your answer is 70. I think the geometry problems are the easiest ones on the test, even though I don't really like geometry. A simple square is any integer greater than 1 that has only 3 positive factors: itself, its square, root, and 1. Which of the following is a simple square? So what we're going to do is we're going to factor these guys. So I'm going to take 121, I'm going to find all the factors. So we have 1 times 121, and we have 11 times 11. So this one has 3 factors, itself, 1, and 11. So that is actually our simple square. Let's show you why 100 is not a simple square. 100 could be 1 times 100, and it can be 2 times 50, and it can be 4 times 25, etc. So a simple square is an integer greater than 1 that has only 3 positive integer factors, itself, its square root, and 1. So 100 has more factors than itself, its square root, and 1. The same with these, like 81 would be 9 times 9, but it would also be 27 times 3. 64 would be 8 times 8, but it would also be 2 times 32. 33 would be, it's not a perfect square, so that one's out because of that. It doesn't have its square. So the only one that works, this could be a tempter, but it's not a perfect square. Simple square has its square root as one of its factors. All right. Number 7, moving right along. They're getting into the hard problems already here because we're on a grid-in section. In triangles XYZ, XZ is 6/7 of H. So XZ is 6/7 of H. That's what your base is. That's what that means. What is the area of the triangle in terms of H? So the area of a triangle is 1/2. The base is 6/7 H. The height is H. So when we multiply that all out, the 2 is going to cross into the 6 3 times, and so we're going to get the area is 3h squared over 7, and that is answer B. That one wasn't really hard. It's just they just want to check your wording. In terms of H means you leave H in the answer. All right, this one's a blast right here. If A and B are positive integers, A is A to the 1/2 power times B to the 1/3 power, all to the 6 power equals 432. What's the value of A and B? First thing I'm going to do is I'm going to distribute that 6 across by multiplying them. So you get A to the 3rd, B squared equals 432. Then you can just start picking numbers. Put in whatever you want. What I do, I'm a big proponent of doing a factor tree for a lot of things. So I actually did a factor tree for this. So I just did it like this: 2 times 216, 2 times 108, whoops, 108, 2 times 54, 2 times 27, 3 times 9, and 3 times 3. Okay, we want to know what number cubed times what number squared. Well, if I have, how many 2's do I have? 1, 2, 3, 4, 5, should have 6 2's. I lost a 2. 1, 2, 3, 4. Okay, 4. That one wasn't a 2. Okay, so if I circle these, I don't know if this is going to help you at all, but we have 3 3's, right? Okay, so if I could take 3 cubed, and instead of thinking this as 2 to the 4th, I can think of it as 4 squared. So then I'm just going to put in here 4 squared. So A and B, what is the value of A times B? It's going to be 3 times 4, which is 12. I mean, you could have just picked numbers out for these. You could have just started picking 2 here, 3 here. They're going to be smaller numbers, so you didn't have a lot to pick from. But I like using the factor tree. At least I had this eliminated, that there's 3 3's, so that has to be A. And then B, it's squared, so I have 2 sets of 2. So be 4 squared. All right, think factor trees on some of these. All right, back to the easy ones. Okay, what is the greatest 3-digit integer that has a factor of 10? Well, 3-digit integers, so you just have to think this one through. So it's going to be 990, because if you went higher, it'd be a 4-digit integer. Recipe for chili calls for 20 people, so 20 people requires 4 pounds of beans. At this rate, how many pounds? So this is people and this is pounds. So 4 pounds of beans at this rate, how many pounds? That's what we don't know on the bottom. For 150 people. This is the same as 1/5. So we're going to get 5x, I mean, not 1/5, 5, equals 150. And we're going to get x equals 30. So set up a simple ratio. All right, next one. Let's see if I have another board. I don't see it here. Here we go. Okay. When the positive even integer n is increased by 50% of itself, so it's 0.5 of itself, the result is in between 10 and 20. So I just set it equal to some number that would be divisible by 1.5. Let's see what number I set it equal to. Did I seriously do 15? Let's see. I didn't bring a calculator up here. So you get 1.5n equals some number between 10 and 20. So what is one value for n? So if we just put in here, we need an even integer too. So I'm just going to set it equal to 18 and see if what we get for n. So hold on a second. A little bad planning on my part here. 18 divided by 1.5, so we got 12. It actually worked. So one of the numbers could be 12. So I just picked a number right here that was divisible by 1.5. And it had to be even, so don't list an odd number. So one possible value is 12. I don't know what the other ones would be. Okay. The perimeter of a rectangular plot of land is 250 meters. So let's make our land. If the length of one side is 40, what is the area of the plot in square meters? So we have 40 here. It's rectangular, so this has to be 40. The perimeter is 250, so I'm going to take 250 and I'm going to subtract from it 80, and I'm going to get 170. And then I'm going to divide that by 2, and so these sides are going to be 85. We're talking perimeter, and they want to know what the area of it is. So all we have to do is multiply 40, this is where I would use a calculator, times 85, and so we're going to get 3,400. All right. Next, a school ordered $600 worth of light bulbs. Some of the light bulbs cost $1 each, others cost $2 each. So this is one of those coin problems, if you ever did those. So let's let x equal the $1 one. So 1 times x plus 2 times y equals $600. And then we had 2 times as many, let's see, if twice as many $1 bulbs as $2 bulbs were ordered. So twice as many $1 as $2 bulbs were ordered. So we have to take that, it has to look like this. We take 2 times the $2 ones to make the equation balanced. And then we just do some substitution. So we're going to put this in for the x. So we're going to get 4y equals 600. Y equals 150. Yeah, we get 150. Now, they want to know how many light bulbs were ordered altogether, so don't stop there and get all happy. X is going to be 300 because it's twice as many, so the total is going to be 450. All right, tricky problem here, but you have to learn to recognize these. You don't want to FOIL this out. Do you see how it says x minus y equals 20, and here we have an x minus y? We're just going to substitute the 20 in there. So we're going to say 4 times, I'm going to put the 20 next, times the x plus y equals 40. So we can simplify that out again. We could say x plus y equals 40 divided by 80. just going to divide that, and we're going to say x plus y equals 1/2 or 0.5. Okay, tricky. These, they don't expect you to FOIL. If you FOIL it, you're not going to be able to get the answer. You have to recognize this x minus y is right here and just do some substitution. Tricky problem. Okay, is there another one on this page? No. Let's move on to, I do believe, the last page. Okay. A rectangular coordinate system, the center of a circle has coordinates 5, 12. So here we go. Let's draw our little rectangular coordinate system. It has, the center has coordinates 5, 12. So it's going to be here 5, here 12. Let's just do that. So we have 5 and this is 12. The circle touches the x-axis at one point only. What is the radius of the circle? Well, here's going to be the point where it touches, right here. Because the circle is not going to be, if this is the center, this is going to be the farthest point. So the radius is just going to be 12. Believe it or not, that's the answer. It's not that complicated, but you have to know a little bit about circles. If it was any bigger, if the circle was bigger than just touching here like this, it would have to touch in 2 places. And it only touches the x-axis in 1, so you know it has to be that. All right, there's 4 problems on this page. Oh no, okay. All right, this one has a lot of words. The table above gives the voter registration data for the town of Bridgeton at the time of a recent election. In the election, 40% of the voting age population actually voted. If the turnout for the election is defined by the number who actually voted over the number of registered voted, what was the turnout of the election? Okay, so we need to figure out the total voting age population. So we have men and women. We need to add those up. So we're going to get 2,500. We're going to add up the men and women who are registered, so it's 2,200. It says in election 40% of the voting age population actually voted. So how many actually voted? 40% of this. So on the top it's going to be 40% of 2,500. Over the number of registered voters, well, we added men and women together and we got 2,200. You pop those numbers in your calculator and something should pop out. Let's see. I'm going to have to pop it in my calculator because I don't have the answer. 0.4 times 2,500 equals, divided by 2,200 equals 0.454. So don't round it, just keep going. It's 0.5454 until you fill in the spot. Okay, that's it. Alrighty, let's go to the last 2 toughies. The 3-dimensional figure has 2 parallel bases with 18 edges. Line segments are to be drawn connecting vertex V with each of the 11 other vertices in the figure. How many of these segments will not lie on the edge of the figure? Okay, I just totally did this. I just went through and connected them. So from V, I connected it. To here wouldn't count because it's an edge. So let's just start connecting. Let's do the little one on the top first. So it would be 1, 2, 3 on the top. So I'm going to write 3 on the top. Okay, let's do connecting to the bottom now. All right, so we're going to go 1, 2, 3, it gets messy, 4, and 5. So it's going to be 5 connections down on the bottom. So 3 plus 5, so the answer is 8. So hopefully I did that, got those right. 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, let's go on to the last one. In the figure, they kind of like this kind of problem. I've seen this many times. In the figure, we have rectangle points A and C lie in the graph of y equals px cubed. That's the graph, is y equals px cubed, where p is a constant. If the area of ABCD is 4, what's the value of p? So the area is going to be length times width, right? We can figure out this distance because it goes from -1/2 No, we can't figure out that distance. We can figure out the x distance. It goes from -1/2 to 1/2, so that's going to be 1. So if the area is 4, we know that this distance right here has to be 4. 1 times 4 gives you the area. Now we need to find a point that lies on the graph. So we can find C here because we know that there's going to be 2 above the line and 2 below the line. So C has to equal 2. Do you see that? Because we have 2 and 2, and so this would be over 1/2 up 2. So C is going to equal 2. So you either have to do this point because it's on the graph or this point down here. So once you have a point, you have the point on the line is 1/2, 2. All we do is we put it in the equation down there because those are your x, y values. So we're going to say y, which is 2, equals p times 1/2 cubed. So it's going to be 2 times 1/8 p, multiply both sides by 8, you get p equals 16. So these are kind of common. Find a point on the graph and then you just plug it in. These are your x, y values. All right, that is it for Test 6, Section 4.